Okay, this will be applied for most of the DLAB. That means try to understand the circuitry. And how do we do it? First thing, if you're looking on this circuitry, okay, how many IC?
Five.
You 1, 2, 3, 4, 5. Okay, 5 IC. First thing is the IC U1. Do you know what the U1? What is it?
That's 74125.
Just a buffer. That means if pin number 2, 1, pin number 3 output will be 1. If pin number 1 have to be route, enable. And pin number 2, 0, then output will be 0, nothing else. However, make sure pin number 1, they must be routed. Same thing for U1B. Okay? If pin 4 route, logic on pin 5 will be go to pin number 6. And that will be the same for U1, A, B, C, D. That is the first thing. The second thing, you already know U3. The flip-flop. Okay? The flip-flop, if they connect not Q back to input D, that will be telling you okay, they will be toggle every time they get a clock coming in. Okay, if you open the handout for the flip-flop, okay, we already telling you if the not Q connect back into the input D, they will be toggle every time they get a clock go to pin number 3. If it was 0, then when the clock coming in, they will be 1. Or if they 1, clock coming in, they be 0. Okay? And now, on this IC U3A, pin 1 clear, they connect to 5 volt. So nothing to do with that pin number 1. However, pin number 4 preset, they connect to output of U1B. So every time you apply 0 pin number 5, they will be set pin number 5 of the U3A. Okay? So anytime the pin number 5 U1 0, then output U3 Q5 Q pin number 5 will be 1, and that will be connected into the port C pin number 5. You can verify it. They want. And also, normally, okay, U3A pin number 5 will be 1, okay? Only thing is, let's see, number 5, if you get a 0 here, they set, so that will be 5, okay? 1. And otherwise, when they toggle, they will be go to 0. And that is just a U3A. U4. U4 is a binary counter, 191. this counter can do how many things? First thing is they can be loading any number. Pin 11, active low. If you apply 0 at the PA pin number 5, they will be load whatever on pin 0, P1, P2, P3 to the output Q0, Q1, Q2, Q3. Okay? That means you can load any number. And then they can be counting up or down. If you look at into pin number 5, U4, 0 means they count up, 1 means they count down. Okay? They can count up from 0 to 15, then 0. Or they can counting down from 15 down to 0 and go back to 15. Okay? CE mean enable. Counting, they already draw, we don't care. Now, the clock will be go into pin 14. That means this schematic is wrong. They using a bubble here. That is not a bubble. Okay? So if you want the count, you apply P clock. They go here, go into U4. One clock, they counting one number. Okay? Either counting up or counting down. That is just a U4. Okay? And also U4, they can get a two output. RC, active low. DC, active high. Now, what that mean? That means normally, if you're looking at the output U4 pin 13, the logic will be logic 1. Okay? Only thing they going low. Okay? When the counter will be up to 15 or down to 0. Same thing. DC, terminal counting up, counting, active high. That means if you're looking at a pin number 12, normally they high, okay? And they will be go low. Normally they will be low. They go high when they end. Now, you're looking right here. I show you. That is the one. Let's see. Okay, this is a timing diagram for IC 191. First thing you see, they get a load here. When they get a bar over, what that mean? That means 0. They will be load. Now, if you're going down to see, okay, what the load data A, B, C, D equal. A will be 1, B 0, C 1, D 1. What's the number? 1, 1, 0, 1. What's that number in binary?
13.
13, correct. Okay. Now, when the load going low, so the input A, B, C, D will be going to the output. Now we're looking at the output here. QA, QB, QC, QD. So you can get exactly 1, 0, 1, 1. Okay. So that means you can load that number. So you can load any number you want. Okay. In order to load it, then you have to be applied load equal 0 and whatever A, B, C, D equal. they will be go to the output. That is a loading. And now for the counting, okay? For the counting, the clock here, okay? The clock they will be counting up or counting down depend on input D yield. D mean active high. 1, they will be counting down. 0, see bar over, they're counting up. And now you see right here the 0. That means the counter will be counting up. And after that, you can see now here, if they load 13 and now they apply the clock 0 to 1 here, they will be going down to number 14. Okay? They will be 14 mean 1, 1, 1, 0. And now, after 14, they get a next clock transition, 0 to 1. And they will be go to number 15. You can see that 1, 1, 1, 1, 15. Okay. Now, when they go to number 15, see what happened to output RCO. RCO normally high. When they going up to 15, they going low. Then they going high. That means go up. Okay. And also maximum minimum. Okay. Terminal count. Normally they low. When they reach 15, they go high. Okay. That is the actual output. They just let the people know I already reached number 15 for one counting cycle. And the same thing happened here. Okay. When you get the counting down, that's what they say, counting down. Okay. When they're counting down to number 1, and after number 1, they will be counting down to number 0. So when they reach 0, then now you can see RCO going low again, and max time, minimum time, they're going high. Just let the people know, okay? They already down to 0, then go back to 50. So, in order to understand how can we do, okay? But I can tell you what about U5. If you're looking at the date, more file be downloaded today, talking about more IC or IC data, you can see this IC, 74244. That's just a buffer, okay? Pin number 1 will be controlled this for input output here. Pin number 19 control the second for input output here. Okay. Now they routed pin 1 and pin 19. That means they will be let the input pin 2, 4, 6, 8 automatically go through it to the output pin 12 for 16, 18. And also input from pin 3, 5, 7, 9 will be go into pin 11, 13. Okay, so normally if you get the data at 2A, 1A, 2A, 3A, 4, they will be go into here. Okay, and they go around back into the input of the U4. And output of the U4 coming out, they will be go to that part right here and go to port C for verification. Okay. Now, in order to do the lab, what they already
Ma'am, I had a
tell you.
question on that.
What?
I had a question on the schematic.
Schematic? Okay. Yeah.
On U4 pin 14, did you say that pin 14 should not or should be active low?
Pin 14. U4?
Correct.
I'm looking for pin 14. That's a clock.
Right.
That's supposed to be positive.
So should there be a bubble there? Yes or
No,
no?
no bubble.
Okay, so that's a mistake there.
Right, mistake from a company.
Okay, but there should be no bubble there.
Exactly.
Okay, thank you. That's it.
So in order to do the lab, they already telling you. First, number one, you want to load this number. Load this number. Load this number. Load this number. Okay. Number 5. They test the output of U3 pin 5 at logical 1. They already telling you what they wanted. Number 6, test counting down, okay, from 15 to 0, okay. Then test counting up from 0 to 15, and also test counter automatic count down from 15 to 14. That means they want to, first thing they want to test the load data. You apply load data here, they go up here, they go to input of U4, okay? And when you apply the load, they will be go into here, and you can verify from pin 1, pin 2, pin 3, pin 4. All the load will be go that way. They can be load 0101, 1011, whatever number. That is the load. Okay? So in order to do, then what you need to do, complete this table. Okay, I'm telling you. Now they say they want test load 1010. Then what logic in the load here? You want to load, what logic?
0. Logic 0.
Logic 0, okay? The thing is you can see star right here, that means active load. And if they load the number 1010, so you have the 1, okay, then 0, then 1, then 0. And you change it into the hexadecimal, 0x0a. Make sure you can follow it. Anything you don't understand, then you have to stop me. I try to help you. The thing is, a main thing in this, the TechII will be working on the digital lab. Okay? You cannot get away. So now, next they say, I want load 0101. So this guy still be load 0. Okay? Then 0, then 1, then 0, then 1. So you change to the height, they will be 0x05. And now load 0. So this still be load on 0, 0, 0, 0, 0. Change to the hexadecimal. Okay, 0x00. And now that's the load number on 1. So still be 0. And they still be 1, 1, 1, 1. And that will be 0x0f. Okay? Up to this point for port A. Okay, so any question up to the test number 4?
Mr. Pham, I have a question.
Yeah, go ahead.
Okay, so basically, what is the purpose of this test from test 1 to 4? Is just to test how the circuit is working? Why it's necessary to load in the circuit the 0x0A, 0x05, 0x00?
Okay. Why?
You're testing all of the functions of the IC.
Basically, it's just to test the machine, just to test the hardware, how this is working, right?
Exactly. Now, how many functions for that counter here? First thing to get a function will be load. Okay? You can load any number from P0, 1, 2, 3 to the output Q0, 1, 2, 3. Any number you want.
Okay.
Now, the question is, why normally we testing a 1 then 0, 1 then 0, right? Then we testing 0, 1, 0, 1. Okay, I can tell you. For the digital, each input or output, you must be testing with the true logic. Testing logic 0, then you must be testing with logic 1. That means if before you apply pin 3, 0, then later on you have to test pin 3 with logic 1. Okay?
Okay, got it.
Now, why we don't test on 0 or on 1? And we have to test 1, then the next have to be 0. The reason is, if you test both pin 0, if they short together, you never know.
Got it. Okay, makes sense. Thank you.
Okay? So that's why digital must be testing that way, engineer testing. Okay? Just a minute.
Thank you.
Okay? So that's why we can test the different logic. Okay? Now, we'll try to help you.
Hey, Mr. Pham,
Right. Okay.
just one quick question. I basically understand what you're saying. On number 4, that's you're doing all 1 so you can get 0x0f, correct?
Correct.
And then on number 6, where you do the test countdown, it's almost like you're unloading. Is that correct?
Loading again.
No. Number 6, where it's test countdown.
We're not loading. But I'm not going up to that point yet.
Okay.
All right, right now, I'm talking about up to number 4. Loading number. You understand for testing, you apply the input. Then
yeah, I got all of that, Mr. Pham. Thanks a lot.
Yeah, then you measure the output. Okay, so in this system, you get a port A, port B, port C, port D. Normally, we assign for port A will be input to the circuit. Port B will be input. Port D will be input, but port C will be using the output. Okay? So the first thing you apply input 0x0A, and now go into the port C. You tap the load here. Okay? You will be reading the output, and when we're doing a calculation, we know we want that to be 0A. You load A, then you get A. You load 5, you get 5. Okay, so that is the test number 1. So in the test number 1 here, port C, okay, the problem made, you need to understand for the math data. Okay, why using math data? Port C, they get a 8 pin. 1, 2, 3, 4, 5, 6, up to pin number 8. When you try to tell the computer reading port C, they don't know anything. They read on 8 pin. Okay? They read all. However, now you have to tell, okay, some pin I'm not using. So I want to mark them out. Mask, what that means? Whatever computer read, we want to mark them out. Okay? So QA, I using it. I put 1. I put 1. I put 1. I put 1. Okay? And this also using it. I put 1. And this a pin not using. Put 0. 0. 0. Okay? So that means normally when the computer read, they throw it away. Whatever, pin 6, pin 7, pin 8. And also they can throw it away. Pin number 5, depend what you want. Okay? Now, normally, if you're converting the math here, there will be 1 and that will be a F. However, on the first test, you testing load 1010. That means you're doing nothing with this pin number 5. So the math I will be using 1, 1, 1, 1. That will be 0, F. That is the math data. So when the computer, they reading port C, they throw it away. All everything right here. The thing is you see, I put don't care. That means we don't care, no matter what 0 or 1. We want only pin 1 to pin 4. So I want that to be F only. Okay? So basically on your program, you can say write to port A, this data 0x0A, then you can reading port C, and you want the output to be 0A. Okay, now P cop, that means if this number, test number 1, it failed, which one caused the problem? They say U1, U4, U5. So now we go in schematic in here. You want to load, you write 1010 here, they go this way. Okay, they go to here. So when you apply, the load will be 0, they go into load here, and whatever here will go in output here, 1010, and they go in output here, 1010. If they not part some wrong, so the cause of the problem can be U5, 1, can be U4, second one, can be U1. That means U1, U4, U5 will cause the problem. I given you example. If I did connect U1 pin 6 to pin 11, that means I remove the wire from U1 pin 6, okay, to pin U4 11. Guarantee you run the test, they will be failed. The thing is they cannot loading whatever here to that output here. So that's why when they fail, then you can see which IC involved in the test, okay? So if I'm doing it, they fail. First thing I can do, I can check either way. For example, pin 9 supposed to be 1, pin 7 supposed to be 1, pin 12 supposed to be 1, okay? So you can check it out, take a meter, DMM, and measure to see what you get on pin number 12. You suppose you get a logical 1. That means around 3 volt, 4 volt, 5 volt, 2.5 volt, okay? If you not get the output here to be a logic 1, then you go back to pin number 8. Pin number 8, if you get the logical 1 here and do not get here, that means something wrong with U5. Okay? That is how to troubleshoot it to find the problem. Okay? So normally after your guy can understand how the circuitry working and you develop your software, you build your circuitry, you run it part, and now I will be insert the fault. I will be make it not part. For example, I remove the Y like I said in here. They fail. Now you must be telling me what you have to do to solving the problem. Okay? That is how we fix it. That's what your job at the company. You run the test, fail, and now you must be know how to fix it. Okay? So right now we on the process. It try to helping you to do your lab. Okay? So now you can coding your program, right? You can apply port A here, apply port A here. I already given you the test program right here. Okay? Test number 1 here. You see that? I already given you one test. That must be test title, that number, test title already in the table. Expect data 0x0A, map data 0x0F, PCOP U1, U4, U5. Then you say write to port A. Then this is my program. You don't worry about that. That will be telling you. Computer will be reading port C and they compare to what you want 0A. If the same, they pass. If different, they fail. That is done for test number 1. Up until this point, you can see you get any question or anything. I said you must do it, okay? You don't want to stay with me until I retire. Okay, and now I can tell you, if I want to do a test number 2, okay, I try to say insert row, okay, whatever, I don't care. Now, you just copy test number 1. Copy and paste them to make a test number 2. So you change this will be test number 2. Okay. Title will be changed to 0101. That from port A. 0101. Okay. Expect data. I want it to be 05. Okay. Map data or PCOP. If I'm looking here, okay, 05 right here. Map data. I'm not let you typing in. PCOP, no. That means whatever in the test 1 will be the same for test 2, test 3, test 4. Okay? So basically, you don't need test number 2. Okay? You don't need that guy. The same thing on the other one. This guy, same thing. Okay? And now you need to write to port A, and the data will be 0805. And that will be done for test number 2. And you can copy 2 and make a 3. Copy 3, make number 4. Okay? That is very easy to do. Only thing is when you already done for this guy here, you don't care about any circuitry, don't care whatever. Following on the port A, B, C, D, and coding your program. Okay? And now, number 5, they say they want to test the U3 preset. Okay? Then, in here, I'm not allowed you to writing anything in here. That means on the test U3 preset, you don't have to write to port A. You can go to port C right here. That's number 5. Okay? Then now, you just coding. Okay? You want the map data, they have to be 1. And also, QA, QB, QC, QD, I don't care. So that's why. Output I want 0, I want 0. And also, on the map data now you must be changing. Okay? The thing is you don't care about QA, QB, QC, QD. So they will be 0. So that's why 0, I want 0. Something wrong. That will be U3. That means they want to test that U3 right here. When you set this load 0, they preset. So that output here, they must be 1. Guarantee they have to be 1. So that will be a testing for preset. Now, testing for counting down. Okay? On this one, port A, I want you to, we already load right here. That's 4. We load output on 1 here. That means the output right now on 1 means 15. So when you're counting down, they go 14. So before, when you set the load equal 0, now you want to count it. Then the load must be 1. Okay? If 0, then they cannot count it. Okay? So load have to be 1 for counting. However, the problem right here, why we want that to be a 1, not 0. Even we already not loading. You see that? 1 means we don't load it. Then this have to be don't care. Okay? Don't care, they can be either 0 or 1. You can enter 0 here, 0 here, 0 here, 0, 0 here. But I want it to enter 1 and 1 and 1 and 1 here. Why? The thing is sometimes the loading going from 0 to 1, they get a circ problem. That means if you set it to be a 0, 0, 0, then they can be loading output to be 0, 0. So we want to still keep it to be a 1, guarantee no matter what happen for the load here, output still be a 1 before we counting down.
Hey, Mr. Pham.
Okay? Now, when we start counting down, you need to apply the clock. They win 15. You apply clock, they go to 14. You can see on that one line right here, 14. Then you apply another clock, they go to 13, 0x, 0D. Okay, now, the computer cannot understand when they're talking to the human about 1, 0. They only talking about decimal. Okay? Or they can talking about hexadecimal. So when you want it to be a 0x0e, that's what you want output to be 0x0e. Okay, they understand. But you want to say, I want output to be 1, 1, 1, 1. They cannot understand. They can understand 0x0e or number 14 the same. The reason is we're using the number decimal. Then we can put everything here into the loop. They can be doing 15 times with the leader code. Okay? If on the way, you have to write 15 tabs. Okay? Separately. That for 15 tabs you can do now. But later on when we're working with the memory, 512 tabs, 1000 tabs, you cannot typing 1000 tabs, no way. So that's why must be using the loop, okay, the for loop. And now if you go to the test program here, I can tell you in here, okay, basically I can get counting up here, okay. That only few line, okay, few line here. We can do 15 times or 16 times, okay. Instead, you have to type in, okay, every single tab. Now, you can see how they do it. First thing you want to do it, okay. So this is the counting up, okay, and we're counting down here. This is the counting down, okay. I supposed to talk to you TechII function today, but cannot next time. Okay, so basically, this is the function how to testing the countdown. First thing, they can tell you for integer j, equal 14 and j greater than 0, then j minus minus. That means 14, then they go to 13, then they go to 12, keep going down. Okay, if they still greater than or equal 0. Okay, then this next line will be you must increment the test number, telling j equal to 14, then they increment one test number. If before test number 6, then now they will be go to 7. And they run second time, they go to 8 and so on. Okay. So on this part right here, that's not a big deal for now. They say if j equal or 14, then p cop equal E1, E4. Otherwise, p cop equal E4. Now, they're telling you right here. Okay. At the beginning, okay, for countdown to 14 right here, you see p cop equal E1, E4. The red will be E1. So that's why we have to using if statement. If j, okay, equal 14, that means the first test of counting down. You want output p cop E1, E4. And the red will be E4. Okay. And also, if j equal 0, math data equal 1F. Let's see. If j equal 0. Right here, counting down. That means when they counting down to 0, then the output of the U3, that means this guy right here, when they count up down to 0, that means you're looking on the timing diagram. You get a 1 here, 1 here, so you can get a 1 in here. So that means they make the clock for U3. That means before the 0, now they go to 1. And this guy will be toggle. So they have to be go to 0. So that's why in the program, we say if j equals 0, that means at the end, then you want math data 1F and p cop will be. That means they happen right here. Okay. If you already done on this thing, we don't worry, just follow it and copy and code it. Okay. Then after that, you apply clock, expect data equal j, and that will be done. Okay. And then we will counting up, same thing. Okay. For j1, j less than 16, j plus plus. And you increment that number, apply the clock, expect equal j, and verify. Okay. So that will be done exactly for this thing. And the last will be counting, okay, down to 14. Okay. So when they go to 14, okay, the thing is when they're counting up to 15, okay, then they're counting up to 15, so they toggle again. That means up and down now will be down. Okay? So that's why when they count up 15, they change it to counting down. automatically, and output will be go down from 15, they will be 14. And also U3 toggle again, they must be 1. Okay, so you can copy 0x 1f and U3 U4. Normally we not pay much attention on the peacock, okay, but we will be pay attention on the data and the math data. Okay, so you get any question on this lab? The thing that I believe we will be very soon to go back into the class. Okay, so this is a very good time to learn to know what to do. Build the circuitry is not hard to do it. Okay, you build 1 time, 2 times, later on not a big deal. However, how you test the circuitry to make sure they're working. Second thing, something going wrong, you're able to know how to do what to do. That's the key point. So we already get to the lab. The lab for the 5 will be 191. What is the next lab? 6 will be 160. I can quickly go to number 6. Okay, don't say. Okay, now this is more simple. If you try data and you cannot make it cut, then you can take to me. I can online with you just about 10 to 15 minutes. Okay, you must make it cut before you can do anything else. Now, on this circuitry, same thing, you get 244 buffer right here. 244 E1. U2 160, that means BCD counter. Binary code decimal. That means they working like the decimal. So this counter only counting from 0 to 9, then go back to 0. Count up only, not down. Okay? And also, they can be load any number you want. And also to get a function for the clear active low. If pin U2 pin 1 low, output clear, that means on output here will be 0. Okay? And RCO, output. If you want it, you need to see the timing right here. Try to learn how to deal with the timing. Same thing. First thing, clear. 0 means clear. 1 not clear. Now when 0, you going down to see. Okay? Output QA, QB, QC, QD. Okay? When this going low, output's not 0, not 0 yet. You see that? They still like this thing. Okay, what happened? They need the clock going 0 to 1. Then now they low 0, 0, 0, 0. Okay? That only telling you one thing. Did I see whatever you want to do? They will be controlled by the clock. This is the clock right here. Okay? No matter what you want to clear, you apply clear 0, but they're not clear yet until you apply the clock. Okay? 0 to 1 transition. Same thing. You want to load any number here to the output, you can apply input load, but they not go into the output until you get the clock going 0 to 1. Same thing, counting up. Okay, you need one clock to counting up, one number. So I already telling you here, I want that load 05, that load 09, that load 02. Okay, then I can test the clear and test U2 counting up 0 to 9, then to 0. And finally, I want to test output RCO right here. RCO here, active high. Normally, they go in 0. Only thing is when the counter reach 0, they go into 1. If you want to see, you can see timing here. See that? RCO. Normally, they low. Only thing when the output 1, okay, 0, 0, 1, that means reach number 9. Then they go high. Just let the people know we reach number 9. Okay? Then you can go into what you need to do is doing port A right here. Okay, right now, input you get a port A, you get a port D, and also it test you need the clock. Okay, so that is the thing you have to do. So first thing you want to say, you load 0101. Port A, you get 0101. Now, port D, enable, you want to be 0. Load to be 0. But clear, they must be 1. Clear 0, you cannot load it. Okay? So you have to write to port A, 0x05. Then you have to write to port D, 0x01. Then you can reading the output here. Okay? You reading load number 5, you can reading number 5. Okay, what the math data, what the peacock you want to do. And loading load here 1, 2, 3. And they can test the U2. Test the clear U2 and U3. Okay, so if you're able to following on the port A, port B, port D, port C to coding your software, I hope I can get something here. Okay, let's see. Now, I don't care that thing. That's number 1. See, that's number 1. That load 0101. Expect data 5. Math data 0F. Peak of 1, 2. Write to port A. Then you have to write to port D. Then you have to apply the clock. Then that's it. Then verify. Okay? This part right here, that's my program. Tell computer to read the data and verify they will be correct or wrong. Then now they say, okay, add more test. Let's copy test 1, paste it into test number 2, 3, 4, 5, whatever you want to do. Okay. On that one, you can write your test counting. You can write how many tests. They can be counting up 1, 2, 3, 4, 5, okay, 6, 7, 8, 9, and 0. You can using the loop function to make a loop. So just few lines they can do for you about 10 tests, okay? I said your guy must be doing your lab at least at this time. You have to get through your test program to run. Make sure they're good. So when we return to the classroom, then will be given to you the park everything, and you have to build and run to verify it's working. Okay? Any question, anything? Even though, the student start from last spring, okay? Now I try make it more simple for you to do, but you're still not doing your digital lab on TechII. You will be staying TechII. Don't ask me why you cannot get certificate. We have to get some to prove it.
Hey, Mr. Pham, I got a question.
Any question? Go ahead.
Yeah. Hey, Mr. Pham. So if and when the class returns, how are they going to do it? Is it going to be returned for the lab only, and the theory is still going to be online? Or
I'm sorry, you get only 1 day or 2 days online. Depend.
Okay, so let me see, because you were breaking. So let me see if I understand this. When we go back, that'll be just for the lab only. And when it comes to theory, what we're doing now, it will continue online.
Exactly.
Okay, that's what I wanted to know.
They don't want to put too many people into one room.
Okay, yeah, that's what I was alluding to.
But at that time, then you can do your lab, right? And we verify. And also, I will be on the Zoom to help you if you get a problem.
And also, you're going to have, depending on the number of people, you may have people give them the parts and they can build their circuit at home. Is that correct?
Exactly. That means they can take out everything.
Hey, Mr. Fanny, when do you expect to we were able to go into the lab?
I thought maybe summer, but but guarantee they have to be fall. Summer will be a short, okay? Short class. That's about less than 2 months.
Okay.
But I guarantee, I'm sure they must be on the fall. Okay, so you already get through everything on the fall. You just try to do the lab, and I can see you can know how to do what to do. Then we will get the certificate.
And you're saying the lab is no more than what it probably will be like 2 days a week as opposed to 4?
For the lab?
Yeah.
You can say normally you can do the lab in the room, or you can take it out. Depending on what your guy wants.
When you say take it out, you mean it it's possible to have the programmers to program our circuits?
You mean take it out?
Yeah, are we going to have access to the programmer outside of the lab in case we want to debug, programming, test our circuits?
Yeah.
Okay.
I can do this way. Okay. Everyone will be take out the whole thing. The box with the part, everything. And also the test set. And try to take you at the school. Make sure you know how to plug it into your computer. Okay. How to run it.
Okay.
When you already know how to do it, then you can take out on upload and get a certain time you must be done. Okay? That
Okay.
means after you already done everything, we have to verify. And if I say, okay, now I get some wrong with the circuitry, do you know what to do or not to fix the problem?
But Mr. Pham, what I was actually alluding to, the actual classroom time for the lab, would you figure it'll be no more than 2 days a week per person because you will have like 20, 30, 40 something people?
I get the total lab maybe 10. Maybe 10. However, that only for the people to testing. That means you get the board already ready.
Mm-hmm.
Okay? Then you can get about 2 days maximum to run your program.
I got you. Thank you very much.
But the thing is, in this program, we can get your guy, we can get the people already done. So I don't care much about that people. I only care about the people not complete for the lab. Maybe they already get through the lecture, but it's not complete for the lab. They still have to do. Only thing is good if you know what to do. You understand that. Right now, not much the lecture. We're supposed to talking about on off the IC. If you download more data for the IC, and we will talking about that one day. Make sure you know every time you want to know how they're working, then you can download that IC and figure out how they're working. Okay. The test before they can get a lot of tests, up to 19 tests, but now, no, they can go up to about 13 tests maximum. Okay, that means cover everything. Cover memory, cover ADC. Okay. Only thing you really understand and really exciting to learn and to do it. Okay, anything else? Okay, I just make sure everyone, you want to get a certificate, you have to do your job. Okay, and I offer to you, you don't know how to do what to do, on Zoom with me. I will be spend time to teach for basic how to complete Excel, how to complete the test program, converting from Excel into the test program. And the build circuitry, that's easy. We can talk one time, and next time you know how to do it. But this thing here, to complete the Excel, you must understand the circuitry. Okay, anything else? Okay, if it's not, see you guys tomorrow.
Mr. Fan, before you go, can you help me with my assignment?
Which one?
Maybe like 5 minutes or less. I just have like a couple questions.
Okay, I stop there.
Right.
And share whatever you can see. Maybe I can help you. Mr. Smith, you don't own, right?
Yes.
5, 6, 7.
Yes.
I have to give you a hard time.
What I've been trying to do is I've been wanting to practice the Tech 1 and Tech 2 homeworks. So I've been spending a lot of time on it. Because this stuff...
You can see I return to your mail. Most of the time will be 4 o'clock in the morning. The thing is when I wake it up, then I looking into the email to see anything. And I can quickly telling you. Okay, now what question here?
My question is here.
What left is it?
3.
Okay, 3 is that's number 3. The left 3, right?
Yeah.
Okay, the left 3. The left 3 means F trigger. D flip flop.
Look like she's missing her clocks. Look like you're missing your clocks. For the D flip-flop, you need positive clock.
Yeah.
So underneath where it says write the port A, you need to put in capital P, and then underscore capital C, then LK, then the parentheses, and then put a semicolon.
Okay, go one by one, Mr. Smith.
Okay. Under port A, you need to have a space where you could write there. For instance, you could, any test.
Okay, now. She already get it passed, right?
Yeah, I got it passed,
No.
but some of them, not all of them.
Okay, now you go into the test program. Okay. On the test program in here, you can say on the test number 1. I'm talking about test number 1 here.
You mean this one?
Yeah, on test number 1. I see that in mine. Okay, you share the screen, right?
Yeah.
Okay, how come they go into mine? Let's see, this is your.
That's mine, yes.
Okay, so now you go into the test program.
Hey, Mr. Pham, if I could jump in and just say one thing. Hey, Viola, yeah. If you look at the bottom, look at that red writing, read that.
Yeah, for each clock test, you must apply positive going transaction.
Exactly. And when you get to like, test number, where it says test clock 2, test clock 3, 4, 5, test clock 6, 7, 8, 9, 10, 11, and 12, underneath port A, you need to have the positive clock.
Okay.
That's what told me the test program. And I can tell you what's wrong with that.
This one here?
Yeah, whatever, on test program.
Okay.
You're going up start the testing.
Start at the beginning, Viola.
Yeah, I'm trying to take this Zoom out of my way. All right.
Right
so
now,
what do you want me to do, Mr. Pham?
Going up to see right now, test 13.
Okay.
Keep going up. Let's see. Okay, now going down, right? Going down to test number one. First test number one. Test number one, you want to do test preset, that's okay. Go test number two. Test clear, that be okay. Test number three.
Test number 3 didn't pass.
They not pass, right?
No.
Okay. Test number three, let's see. Test number one, test number two, test number three. Okay, test number one, test number two, test number three. Oh man. Okay, let's see. Test number three, clock. Okay, test clear 0, 1. Test clear will be data right 0, 1. Correct. Test number three, test clock 1. Expect data 1. Right to port A3. Okay. Try to port A3. That's correct. Okay. Then you apply P clock and expect data in measure. Look like it's okay, right?
Yeah, I think it didn't pass because expected data is 0, 1. So anything with 0, 1, it shouldn't pass, right, on my computer? I'm not sure.
No. You cannot run on your computer to make it pass, right?
Okay.
They must be failed.
Yeah, it fell.
No hardware. They must be failed. Only thing you upload it and Mr. Farm can run. Then they can tell you part of fail.
Okay.
Okay. So look like you doing a right thing. Go to tab number 4. I can see one more. Okay, now. Tab number
clock.
4. You're missing the clock. You can see that.
I'm missing the clock under.
That
Like the
means
port A.
you can see line 60, you get P clock.
Oh, okay.
So that is after you write port A, you have to apply that clock. Copy
Okay.
that, paste them out. After line 73.
Basically, what he's saying is line 74 should be the P clock.
Oh, P clock in here.
Yeah, go ahead, put it in. Go ahead and put it in.
It's P underscore clock.
Better way, copy line 59 or 60. Paste them out. Open, close. Okay, go to line 50, 60.
Line 60.
60. Copy the whole line. Highlight that. Yeah, Control C. And put it after that line. Okay.
After this one, right?
After 73.
After 70.
At the end of port A. Yeah, right there, right there.
Okay.
Enter. Control V. Yeah.
There you go.
And now you go into test number 5. Okay.
And I have to
the
do the same thing with test number 5.
Right, same thing.
Enter.
You
Control.
need a clock for each one.
No.
No. You're supposed to go down.
Yeah.
Keep going.
Keep going.
Keep going.
Keep going.
Keep delete. Oh.
You went too far.
All right.
That's okay. Command doesn't matter.
Okay, okay, stop.
Go all the way back where the P was at. Take the P out.
Okay, go.
Now hit enter.
Now Control V.
Control V.
There you go.
There you go.
Okay.
Go, keep going down.
Keep going down.
I have so many of them.
Okay, do the same way, same thing.
Mm,
After from port A, enter.
Enter.
Control V.
No.
No.
Go down. Go enter.
Enter. Control V.
V.
Go down.
She didn't change the test titles too. She called them all test clear, but she needed to change.
because I was copying from one and just continue. I think that's what happened.
That clear, we don't need that clock.
Do the same for all of them, then you're good.
Okay.
How come they get that clear?
Because I copied everything from, I didn't
man.
change it.
Yeah, but as you go along, you need to change it for each one the way
Yeah,
the
I have to go
Excel
change
says.
it, yeah.
Okay, so now you know the problem.
Okay.
Only thing is when you say, they say that's a clock, then you need that P clock.
Yeah.
Otherwise, they don't need that. Okay?
Okay.
After you're done, compile, make sure they're working and upload it so they can take it out.
Okay, I have a question, one more question before you go.
Yeah.
Let me print this one here. See how like test number 4 is clear 02, but there's nothing here.
That
so
means
what
you
should I
don't
write
have,
on the port A?
that only thing is you don't have to write to port A.
I don't have to write to port A?
Hey, that means I not allow you to write anything. That means on the test number.
That means I'm supposed to take this one out, then there's 0 right to port
The thing
A,
is, I don't know where your
003.
test number. What's the test number?
Test number.
You can going up to see what the test number right now.
Okay.
Right now it's 9. Okay. I want to see test number 4.
Okay, test number
4. Start test number 4.
So there's nothing on test number 4 right to port A. And let's see here.
Where test number 4?
Then go too far down.
Stop, go back up.
Where test number 4?
Right here.
Okay. Test number 4.
Okay, so here I put 0, 0.
Now,
you don't write.
Delete that.
Delete that line.
Delete that line. The thing is, in the Excel, I not allow you to write to port A.
Yeah, that's what.
Take that out.
Okay. I can just delete this one and leave the command, right?
No, we don't care. Delete the whole line.
Oh, okay.
Okay, delete that. Okay, so that's
right.
number 4, number 5, number 6, right?
Yeah, I think I have to go through all of them and change it.
Yeah. You
All
have
right.
to go into your Excel. Okay.
All right. Thank you.
Yeah, no problem.
Thanks,
However,
guys, for help.
make sure you're on test number 8 and 9. Then you have to write to port A again.
Okay.
Okay.
All right.
Just follow the Excel encoding.
All right.
Okay.
Appreciate the help.
Okay, so we'll see you guys tomorrow.
Mr. Fred,
Bye.
Yes, sir.
Thank you.
have you been having any connection issues tonight?
What?
Have you had any connection issues tonight with the computer for Zoom?
Any?
Has the computer been having problems? Has Zoom been having disconnection problems at all?
No.
No, all right. I just wanted to make sure because my computer's been dropping out. All right, thank you. Thank you.
Okay, so far I have no problem. Okay, so we see you guys.
Okay, bye-bye.
Bye-bye.